We're looking at the law of sines and law of cosines today, which is a review from Math 3. So first off, what are oblique triangles? Oblique triangles are not right triangles. So something like a triangle like this would be an acute triangle because all the angles are less than 90 degrees. We label the angles with capital letters, A, B, and C, and the side across from them is a lowercase letter. Okay, we have another, say, obtuse triangle here. This is also an oblique triangle. Angle A, angle B, angle C, side A, side B, side C. This one would be an obtuse triangle because it has an angle greater than 90 degrees. Okay, so the law of sines is written as so. It's the ratio of the sine of A over A plus the sine of B over B equals the sine of C over C. And the little lowercase letters are the side lengths, and the capitalized letters are the angles. The law of cosines is like Pythagorean theorem, but because it's not a right triangle, we have to add on this extra piece right here. Okay. One thing to notice is that law of cosines, whatever side length is by itself is the angle you're going to use in your equation. Okay, so side length by itself, angle you're using in the equation. Some tricks. If your given information is angle, side, angle, or angle, angle, side, or side, side, angle, it's best to use law of sines. If you're given more information about the side length, so side, 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 or side, angle, side, it's best to use law of cosines. What about if I'm given information about angle, angle, angle? That is not enough info to determine what type of triangle we have. Not enough info. Because I could have a triangle with 60 degrees, 60 degrees, and 60 degrees, but I don't know if this side length is a 1, a 1, and a 1, or maybe it's a bigger triangle, so a similar triangle with 60-degree angles. This could be 10, 10, and 10. Same angles, but different side lengths. So we kind of need information about at least one of the side lengths to figure out the remaining angle measures and the remaining side measures. Okay. So example 1, what type of information is given? This looks like an angle and an angle. So angle is the side between or outside. It's outside, so this is angle, angle, side. So I think I'm going to use law of sines here, I'm hoping. Law of sines, you want an angle and a side length that are across from each other so you can build a ratio. So the sine of 42 degrees over 22 inches is equal to the sine of, let's see, I'm looking for the side C. So I actually need angle measure C. So doing a little math, I'm going to do 180 minus 42 degrees minus 22 degrees gives me 116 degrees. Okay, so I get 116 right here. So now I can fill in my ratio. Side angle C is 116 degrees over side C. I'm going to solve by multiplying both sides by C. And that cancels that out. And I'm also going to multiply by 22. That cancels that out. It's 22. So I get C sine 42 degrees is equal to 22 sine of 116 degrees. Divide to get C by itself. So C is equal to, let me plug this into my calculator, sine of 116 divided by sine 42. And you want to make sure your calculator is in degrees mode. Okay, I'm going to round here, so this is 29.551 inches, because that's our units. Okay, number 1. Number 2. Let's go for what type of information is given. This is, I have 2 sides, so this is side with an angle. Outside, so this is angle side. My high school geometry teacher told me that this is the donkey theorem. Okay, so I'm going to go ahead and set up my law of sines here. Sine A over side A is equal to sine of angle B over side B. Remember, you need at least 3 pieces of information. So I have this piece, and this. So just kidding. I have this piece. So I can solve for the one unknown piece. Okay, so the sine of 85 degrees over 15 is equal to the sine of B over 25. I'm going to multiply both sides by 25 to get sine B by itself. So sine B is equal to 25 sine of 85 degrees over 15. And I'm going to get a decimal equivalent and store that number in my calculator. So 25 sine 85 divided by 15 gives me 1.66 ... I'm going to store this as B. Okay, so when I take the sine inverse of my ratio, 1.66, and that's going to equal angle B, my calculator says error. Why? Well, remember, is 1.66, the ratio, 1.66, in your range? No. Remember, the graph of sine only goes up to 1 and down to -1. So 1 and -1. So I get no outputs that are in between, that go up to 1.66. So what does that tell me about this triangle that I'm attempting to create? Well, it means there is no triangle. What this looks like is more like this. Okay, I got a side at 25, and I got a side here. Oh, I have a side here, but my third side is going to be off. It's not going to make it. It's not going to make a triangle. That's what's going on here. Okay? All right, next. So what you have just witnessed is one situation called the ambiguous case. This is what happens when when the given information is angle, side, side. Remember donkey theorem. Donkey theorem gives us weird things here. So what happens is you can end up with 3 different cases. You can get no triangle, 1 triangle, or 2 triangles. So no triangle would look like this. The side length is not long enough to produce a triangle, okay? Or we can get 1 triangle. So 1 triangle can be like a right triangle. Or it can be like if one side is longer, if this side here is longer than this side here, okay? The other thing that can happen is I can end up with 2 possible triangles. So let's say I have a triangle like this. What if I swing this side around? So I'm just going to swing it. Okay, it's going to stay attached there. And it looks like I can attach a piece right there, and I end up with an acute triangle and an obtuse triangle. So what happens is, if you know this side length and this side length. So we're going to say, let's call this side A and side B. So if A is less than B, then you can end up with two triangles. If A is less than B, you can end up with one triangle. Just kidding. 0 triangles. Okay. Now, if A is greater than or equal to B, you'll probably end up with one triangle. Okay. So this is why it's ambiguous. We're not sure how many triangles it's going to produce. All right. So let's look at this third example here. How many triangles are we going to produce given this information? So, well, what do you know? It's side, side, angle. Okay, it's 2 sides and the angle outside. So what I want to do is look at side A. Okay, so the angle across from the side across from our given angle. And what is its relationship to B? So it looks like 12 is something to 31. 12 is definitely less than 31. So I'm either going to end up with one triangle or 2 triangles. Okay, so I can see that if I take this side length 12, I can actually spin it around, rotate it, and I think it'll match back up with my, like another little piece will fit right there. So I'm going to end up with 2 triangles that look like this. One that is like this, and one that is obtuse, like that. So I get A, C, and B. The side length is still 31. That one's 12, 31. A, C, and B. And that one's 12. So we just need to solve for this third. We're going to solve for angle B really quick. But remember, we're going to have to solve twice since there's 2 different triangles we could possibly make. All right. So the sine of A is 20.5 degrees over its side length 12 is equal to the sine of B over 31. Okay. And I get multiplied by 31. That cancels. The sine of B is equal to 31 sine 20.50 over 12. When I solve with my inverse sine of my ratio, so 31 sine 20.5 over 12, B is going to be about equal to 64.8 degrees. Okay, where is that angle? Which triangle? Well, that is that angle right there, 64.8 degrees. So that's for my acute triangle. What about my obtuse triangle? Okay, so I'm going to have another answer. This part right there, that's 64.8 degrees. Well, guess what? When I swing this side over, that's a 12 as well. So this angle here is the same as this angle here. Okay, so if this angle is 64.8 degrees, what is that one? Well, you're a sleuth, and you figured out that for the obtuse angle, B is going to be equal to the supplementary angle, 180 degrees minus 64.8 degrees. So B is equal to 115.2 degrees, and it's about equal to because we rounded. So these are both answers, depending on which triangle we're going to use. They're both possible.